Graph the system of inequalities. X plus 4y is greater than or equal to negative 12. 3x minus y is less than or equal to negative 9. Okay, what we're looking at here are two linear inequalities, meaning x and the y variables are both raised to the positive first power, exponent of positive 1, in both, x to the first, y to the first, in both of these inequalities. Inequality is, we have an inequality symbol instead of an equal sign, so these are inequalities, not equations. Now, the difference between graphing an equation and graphing an inequality, perhaps I could show you briefly, is when you graph an equation, the graph of an equation like ax plus by equals c versus the graph of an inequality such as ax plus by is, say, less than or equal to c. Well, here's like just a couple of xy rectangular coordinate systems. What you would have, let's see if we can just maybe do this in color. What you would have with an equation where you have an equal sign between the two sides, between left and right sides, is equation's graph as a line. However, the graph of an inequality graphs as a line, whether that's solid or broken depends on whether you have or equal to or not. When you have or equal to, this line is solid, and when you don't have or equal to, like just less than or greater than, then what you have is a dashed line. But the big difference between the graph of an equation and the graph of an inequality is not only does the inequality graph have a line, but one of the two sides of the line is shaded. I don't know which side would be shaded without going through the steps, but I'm just going to say, for the purpose of demonstration, that one of the sides of the inequality of the line that we get is shaded. Okay, so there's the big difference in the two graphs. We're expecting, when we're solving the system together, we're expecting to graph each one of these two inequalities. Each one is going to have a boundary line and one side shaded. Then when we're looking for the solution to the entire system, we're going to look for where those two graphs, the two individual graphs, overlap. Okay, so let's graph each inequality. I'm going to make the first inequality blue. So I'm going to say we're going to graph inequality number 1 in blue. So I'm going to make x plus 4y is greater than or equal to negative 12. I'm always checking to make sure I wrote down the correct inequality. X plus 4y is greater than or equal to negative 12. And we're going to make the other inequality, we're going to label that as inequality number 2. And I'm going to associate the color green with inequality number 2. So let's go ahead and write that over here. We're going to graph inequality number 2 in green. And it is 3x minus y is less than or equal to negative 9. Okay, so let's, we're just kind of laying out the process here. Okay, the way to graph an inequality. The first step is to graph, I'm showing these now as steps. Step 1, graph the boundary line. The boundary line. Why do we call the line associated with an inequality graph a boundary line? Because it's the boundary line between the shaded side, and the unshaded side. So I'm going to abbreviate this BL, and we'll use that later. So graph the boundary line. What we do is we write the original inequality, the two sides, the two expressions, left side and right side, as these are, but we replace the inequality symbol with equal, the equal sign. Equal equations, as we said, they graph as a line. This is the equation of the line, the boundary line, that's associated with the inequality. So we can graph this in any way we want. I'm going to graph by intercepts because we're not going to get any fractions. Here's graphing by intercepts. I'm going to make a little coordinate table. Graphing by intercepts means we're going to use zeros for each variable and solve for the other variable. So 0 for x, we're going to solve for y. 0 for y, we're going to solve for x. Now, get ready for substitution. X plus 4y equals negative 12. We're going to put a 0 in for x. 0 for x plus 4y equals negative 12. This becomes 4y equals negative 12. We're going to divide both sides by 4. We get y equals negative 3. Negative 3. So here's the y-intercept. Now we're going to find the other intercept. We're going to use x plus 4y equals negative 12. And this time we're going to put a 0 in for y. 0 in for y. 4 times 0 is 0 equals negative 12. X plus 0 is x equals negative 12. So the x-intercept is happening at negative 12. And we can go graph these 2 points and connect those with a line. Okay, the y-intercept for the blue inequality is 0, down 3, negative 1, negative 2, negative 3. 0, negative 3. And the x-intercept is happening at negative 12, not up or down at all. Negative 12, 0. 3, 0, negative 3, and negative 12, 0. We're going to connect those with a line. Now, we look back at what we said. When the inequality has or equal to, the boundary line is going to be solid. Solid boundary line. Because we have greater than or equal to. Or equal to. That's what makes it solid. So we're going to lay a ruler down and carefully graph points. You graph a solid boundary line between the points. Okay? And now we're going to move on to our shading step. To shade, this is going to be step 2 of graphing an inequality. What we're going to need is we're going to need to find a good test point. We're going to choose a test point. Choose a test point. Test point. And I'm going to abbreviate that with TP. Choose a test point, not, what's a good test point? Not on the boundary line. Any point that's not on the boundary line. When it's available, use the intercept. Use the origin as a test point. Right now, for this equation, for this inequality, this test point for the origin 0, 0 is not on the boundary. The boundary line's like way over here for inequality 1. We're going to use this test point. It's clearly on this side, not that side, but this side of the line, of the boundary line. So we're going to use 0, 0. Which has an x coordinate of 0 and a y coordinate of 0, and we're going to substitute these coordinates, the coordinates of the test point, into the original inequality. And then we're going to see if we get a true or false. Okay, so the original inequality is x plus 4y is greater than or equal to negative 12. I'm going to get ready for substitution. When we say the variable name, we open empty parentheses. And here are the values of our test point. X is 0 and y is 0. And we're going to see, is this going to turn out true? So we put a question mark over that. Now we're going to simplify and see whether we get a true or false out of our inequality using having the inserted test points. Okay, 4 times 0 is 0. Now we add this 0. 0 plus 0 is 0. Now, we look at this statement, and we're asking the question. It's a true or false question. Is this true? Is it true to say that 0 is greater than or equal to negative 12? Well, if only one or the other has to be true. We know that 0 is not equal to negative 12, but a non-negative number is always greater than a negative number. So the greater than part, 0 is greater than negative 12. This is true. Only one of those two parts, greater than or equal to, has to be true to consider this whole thing true. Greater than or equal to. Yes, it's true. 0 is greater than or equal to 12. Okay, here's how we interpret that. When we get a true, this test point gave us true, we shade the same side as the test point. If we were to get a false in the original inequality, if we were to get false, we would, for this test point, we would shade the other side away from the test point. But putting the test point in, we actually get true. And so we're going to shade toward, you go to the boundary line and shade toward the test point. And I use 90-degree angle lines. I'm shading the same side of the boundary line as the test point. That's it. That's the graph. This is the graph in blue of inequality number 1. Now we're going to shift over and graph inequality number 2. So step 1 is the boundary line. Step 1, graph the boundary line. And before I forget to, let me just put a label on this. Let me go back here. Step 2 down here was shade one side. Shade one side. We're determining the shading in step 2. Okay? Step 1 was the boundary line. Step 2 is the choosing which side to shade. Okay, so here we go. We see that our inequality has a left side expression of 3x minus y and a right side expression of negative 9. To graph a boundary line, we're going to replace the inequality symbol with equals, because equations are always what give us linear equations, give us a line, graph us a line. So I notice that C is in standard form. C is a multiple of A and B in standard form, so we're going to definitely graph by intercepts again, because we're not going to get any fractions. Fractions are kind of a drag when you're graphing. So these are going to leave us with integer coordinates, which is going to be really nice. Here's graphing by intercepts. We're going to end up getting 0, comma, solve for y. We'll put a 0 in for x, solve for y again, and put a 0 in for y and solve for x. Is going to give us the x-intercept. These are the y and the x-intercept. Okay, get our equation for the boundary line ready. 3x minus y for substitution. This time we're going to put a 0 in for x and solve for y. Here we have the opposite of x equals negative 9. We can divide by or multiply by negative 1. I'm just going to divide both sides by negative 1, and we get y equals 9. Y equals 9. So we have our first intercept, and now we're going to get the equation ready. 3x minus y equals negative 9. And this time we're putting a 0 in for y. Put a 0 in for y. What we get is 3x, 3x minus 0 is 3x equals negative 9. Divide both sides by 3. And we get a value of x equals negative 3. So here's where our intercepts are, and we can take these right over to our graph, and now we're graphing the inequality for inequality number 2. Here's the boundary line part. 0, comma 9. 0 means don't go left or right at all for x, and up 9. 1, 2, let's see, 9 is right here. This would be the y-intercept for the boundary line for inequality number 2. Negative 3 in the x, 0. Negative 3, don't go up or down at all. Here's the x-intercept for inequality number 2, boundary line. So we're going to connect these two. with a line. Should it be solid? Yes, we're going to have another solid boundary line because inequality number 2 is less than or equal to. It's the or equal to that determines that we're going to get a solid boundary line. If we did not have or equal to, just less than, we would dash this green boundary line. But we have or equal to, so we're going to make it solid. So here comes a solid boundary line for inequality number 2. Now we are choosing to determine which side is going to be shaded. So here comes step 2. Step 2 is shade one side. We're going to determine which side of the boundary line should be shaded. Shade one side. And we're going to, I don't know, is the test point that we used for equation for inequality 1, is it available? Yes, it is, because it's nowhere near this green boundary line for inequality number 2. Let's use the same test point. So we're going to use the same test point. The same test point of 0, 0, the origin, where the first 0 is an x value and the second 0 is a y value, and we're going to substitute that into inequality number 2 for x and y. So the inequality, always go back in the shading step to the original inequality. 3x minus y is less than or equal to -9. And prepare the inequality for substitution. Now we're going to substitute in the x and y values. X we're going to replace with 0 from the test point. Y we're going to replace with 0 from the test point. And put a question mark over the inequality symbol. And we're going to go back now and simplify and see if we have a true or a false conclusion. Okay, here we go. 3 times 0 is 0. 0 minus 0 is 0. Is 0 less than or equal to -9? And that is the question that we're going to have to answer. Is it? Well, I would say when you're looking at 0 is not equal to 9, you can definitely say they're two different numbers, so 0 is not equal to 9. But is 0 less than 9? 0 is not less than 9. 0 is greater than 9. Than negative. Excuse me. 0 is less. It is not less than a negative number. 0 is to the right of -9. So we would determine that this is false. This is false. Because 0 is not less than -9, and 0 is not equal to -9. So that's when both parts fail or false, less than or equal to, we determine that we get a false for this test point. And remember when we said in the first part, if we get a false for the test point, we don't shade the same side of the boundary line as the test point. We shade the other side. The other side. Here's the boundary line. The test point is on this side. There's two sides, this side and that side. Which side are we going to shade? If we get a false, we're going to shade the other side. So we shade the other side from the test point. And I'm using 90-degree lines from the boundary line. And I'm shading away from the test point. And we're shading the opposite side, the other side from the test point. Okay, we've shaded both sides. We've shaded and completed the graphing of both of these inequalities. Now, to show the graph of the entire solution, the solution that is only the overlap region. Like here's hatching, the blue hatching. Here's hatching that's green hatching. But where's their cross hatching? Cross hatching is all in this area where you see small squares. So here's the way to determine the proper region. That is solutions to both inequalities. That's what we're really looking at here. Now if we were to come down on the original blue, here's how we're going to determine the limits of the final. I'm coming down on the blue line until we hit the green line. The one boundary line, and then it turns. We follow the green line now. follow the green line up. These are the limits of the shading that they have in common. And I'm just going to do it this way. See, I'm going from the blue line to the green line, from the blue boundary line to the green boundary line. All of this would be what I'm showing in red would be the solution. Now, which of the answer choices match this? When you look closely at the intercepts for the boundary lines, the location of the boundary lines, and the correctly shaded region, what I'm seeing here clearly, there's a little bit of shading below the x-axis. There's a little bit of shading below our x-axis where we constructed it. There's a gap between the y-axis and the beginning of the shading. Use some visual clues. Verify that the intercepts for each of the boundary lines is correct and that the correct region of overlap is shaded. And we really should select answer choice C. This is correct. None of the others look like our graph. Only the red part. That's what you're looking at. Only the region of overlap. And the limits. The correct response for this question is C.